we are going to do a demonstration with this energy ball. When we connect the end of this wire to both metal parts of the ball, what do you think will happen?
It's going to light up.
Let's see. What happened?
The ball lit up.
So why do you think that the wire made the ball light up?
It allowed the electricity to flow.
Do you think we can use something else to make the ball light up?
Metal, maybe?
Okay, what about us? Do you think humans can make the ball light up if we connect the metal ends?
Maybe, but we aren't metal.
Let's find out.
Alright, so now we're going to get everyone to stand up in a circle and we're going to hold hands. So me and Miss Mary let go of hands. And then alright, good job. Everyone can go back to their seats.
So what does this mean?
We conducted electricity.
That's right, this means that electricity can flow through humans. For this lesson, we will investigate the question, what objects can and can't be used to light a bulb? We just saw that humans conduct electricity, but what is electricity anyway?
So I'm going to come around and pass out your vocabulary sheet, and you're going to fill out the electricity vocab on your sheets. And I'm going to post it over here on the dot cam. And the definition is, electricity is the flow of negatively charged particles.
So what evidence did you observe that indicated that electrical energy was moving?
The ball lit up and it made sound.
That's right. How do we have to arrange ourselves to make this happen?
We stood in a circle and we made sure that we were connected.
So we stood in a circle. What do you predict would have happened if someone let go of their neighbor's hand in the circle?
The ball wouldn't light up and it wouldn't buzz.
Right. So we saw that the ball didn't light up. Based on this, what is necessary for electricity to flow?
There has to be a complete loop.
That's right. We had to make a circle in order for electricity to flow. In science, we call this a circuit, or a pathway for flowing electricity. Everyone say it with me. Circuit. So now we're going to post the definition of circuit on the board. Make sure you're filling this out on your vocabulary sheet. So notice how the word circuit is similar to the word circle. This can help us remember that a circuit must make a complete circle. But circuits don't always have to be in a circle. They can be any shape, as long as they are fully enclosed. As a class, let's draw out all the parts of a circuit on the board.
Alright, so what are some things we need in order to create a circuit? So, let's say to power a remote control at your house.
You need a power source.
Okay? So that's going to be our battery.
We need wires too.
Alright, what else?
And we need a light bulb.
Alright. This is our light bulb. And so that's our complete circuit, so correct. So now, we're going to pass out our materials to you to make your own circuit. So please remember that whenever you're making your circuit, the light bulb might appear a little bit dull because we have our light in our room as well. And also, we're going to use everything we just learned about circuits. You're going to work with your teammates to make your own circuits. Before we begin, I want to make sure none of you accidentally create a short circuit. So that's one of our safety concerns, because short circuits are dangerous, and so we want to avoid creating them. So what is a short circuit anyway? A short circuit is actually when you connect one wire from one end of the battery to the other. So this is what we do not want to do. So are we going to create any short circuits?
No.
Alright, so now we're going to go ahead and pass out job cards, so everyone should have a different job from last week. And we're going to also, recorders, make sure everyone has a worksheet at your table. And then technicians, make sure you come up and get the materials for your group.
So now I'm going to pass out your lab data sheet, which is what you're going to be recording all of the data you get from your experiment on. So let's go ahead and take a look at our data sheet, and let's look at what we're testing for number 1. So what's the first thing we're testing?
A penny.
Who thinks a penny will make the small light bulb light up?
I do because it's metal.
Okay, that's a good prediction. Make sure you're recording your predictions on your sheet. So now I'm going to show you how to test the penny. So first you're going to go ahead and do your simple circuit, like we all just did, where you make your simple circuit and your light bulb lights up. And you get your penny. You're going to connect one end of the light bulb to your wire, then you're going to connect the penny to the other end of the wire, and then you're going to connect the end of the wire on your light bulb to the penny, and you're going to see if it lights up. So what's happening?
The bulb lit up.
That's right, the bulb lights up. So on your observation sheet next to your prediction, you're going to write yes for the penny. So now we're going to do the second experiment, which is a piece of cotton. So what's your prediction about the cotton? Will it allow the bulb to light up?
No.
No, you don't think so? All right, let's go ahead and test it. So we're going to test the cotton ball like we did the penny, and we see that it doesn't light up. So why do you think it's not lighting up?
No, because it was fluffy and it had too many gaps in it.
Okay, maybe that's it. So right now you're going to make sure that you have recorded your prediction and you write down your observation for no, that it did not light up. So for our penny that we tested, it lit up because it's something called a conductor. So now we're going to write the definition for conductor on the board, and make sure you're filling out your sheet, your vocabulary sheet, as I write the definition. So a conductor is a material that allows electricity to flow. So a conductor is a material that allows electricity to flow. And we saw that our penny was a conductor. The cotton, however, is something that you call an insulator. Now I'm going to write the definition for insulator on the board. Just going to erase our short circuit. Again, an insulator is a material that does not allow electricity to flow. Everyone repeat after me. Insulator.
Insulator.
Very good. Okay, so go ahead and write conductor for the penny and insulator for the cotton ball on the third column of your data sheet. So you can skip this column for the rest of the items that you're about to test. And so now you can go ahead with your partner and test the rest of your items, 3 through 11. But make sure you're writing your predictions before you test your item. And then as soon as you test your item, you write down your observation of whether or not the light bulb lit up. So again, you want to make sure your material is touching the wire that's touching the battery and touching the wire coming off of the light bulb. So make sure you're not just making another simple circuit by touching the wire from the battery to the wire of the light bulb. So now you may go ahead and do your investigation. Now we've seen how different materials can be conductors and insulators. In our past investigation, we were looking at how electricity was used to create light. What else besides light does electricity produce in our investigation?
The light bulb also creates heat.
That's right. We say the electrical energy was transformed or changed into light energy and heat energy. The electricity also created heat here. That's why light bulbs get hot when they're on. In a lamp, is the electrical energy changed totally into light energy?
No.
How do you know?
I can touch the light bulb and feel it's hot.
That's right. So what do we use switches for?
To turn the lights on and off.
That's right. What objects or things can you think of that have switches?
Hair dryers?
Very good. So what do you think switches do in a circuit?
They stop the flow of electricity.
That's right. A switch can either start or stop the flow of electricity in a circuit. Now, can I get the technicians to gather your supplies and give them to one of us, please? So what is electricity?
Electricity is a form of energy.
Okay, so we're going to post the definition of electricity on the board. Electricity is the flow of electrical charge caused by the flow of negatively charged particles. So now we're going to make a human circuit and act out what electricity does to a light bulb when a conductor or insulator is added. But remember, electricity is the flow of negatively charged particles. So that's what is going around the circuit, is the negatively charged particles to make the light bulb light up. So electricity is going to travel through our simple circuit whenever it's connecting. So let's connect our circuit and see what happens. Okay, and now electricity, you can flow through the circuit. Very good. And what's going to happen if we add an insulator? That's right, electricity stops flowing and the light bulb turns off. Okay, what happens if we add a conductor? That's right, electricity flows again and the light bulb turns back on. So now that we did a human circuit, we're going to go over our electricity worksheet that we filled out when we were doing our investigation. So looking at your electricity worksheet, what materials did you add to the circuit that made the small light bulb light up?
A penny, aluminum foil, paper clip, and metal part of a pencil.
That's right. What do these things all have in common? What are they made of?
They're all made of metal.
Very good. And what do you call these items?
Conductors.
That's right. A conductor is generally made out of metal and they allow electricity to flow, which is why the small bulb lit up. However, it's important to remember that not all conductors are made of metal. So now I'm going to post a diagram on the dot cam of what a conductor looks like on the particle level. So an object is a conductor if it allows particles to move around freely. As you can see on the diagram of the conductor, the negatively charged particles are able to move around freely. What material placed in the pathway did not make the small light bulb light up?
Wood, straw, cotton, a rubber band, styrofoam, and paper.
Very good. So what makes them different from the conductors?
They're not made out of metal.
Okay, and what do we call these things?
Insulators.
That's right. Usually anything that is non-metal is an insulator because it doesn't allow electricity to flow easily. So let's look back at the diagram of insulators and conductors on the particle level, and you'll notice that the insulators do not allow the negatively charged particles to flow around freely, and that's why electricity cannot flow through insulators. So now let's talk about the pencil. Is it a conductor or an insulator?
It's a conductor and an insulator.
That's right. So the pencil is kind of tricky because it's both a conductor and an insulator depending on what part of the pencil you're talking about. So if you tested the metal part of the graphite of the pencil, if your pencil was sharpened, or if you tested the metal at the eraser, it made the light bulb light up because those are both conductors. Now if you tested the rubber part of the eraser on the pencil, it did not allow the light bulb to light up because rubber is an example of an insulator. So now let's look at the bottom of the worksheet, and we're going to take a minute to answer the first few questions. Explain why a conductor can light a light bulb, but an insulator can't.
Negatively charged particles can easily flow through a conductor, but they can't flow very easily through an insulator.
That's right. So if you remember our diagram that we showed of conductors and insulators, we saw that negatively charged particles can flow freely through a conductor, and those negatively charged particles are called electrons. They're part of an atom. So those electrons can flow freely through a conductor, but not freely in an insulator. So now let's look at question 1. So what materials allow electricity to move easily?
Conductors.
That's right, a conductor. So now we're going to look at question 2. So what do you call the materials that cover electrical wirings that keep us safe from getting shocked?
Insulators.
Very good. So what are some examples of how insulators are used to keep us safe?
We wrap wires in rubber so that we don't get accidentally shocked when we touch them.
That's right. So think of an object that uses a buzzer.
An alarm clock or a doorbell?
Very good. Would the buzzer work the same way as our circuit with the switch? How?
Yes, maybe it makes a circuit like we did.
So all of those buzzers work in similar ways. For example, when you push the button on a doorbell, it connects 2 wires, like flipping a switch, which allows electricity to flow, and the buzzer makes a noise. So it works similar to how we saw this simple circuit with the light bulb. So are humans conductors or insulators?
Conductors.
So when it's thundering and lightning outside, you should not go swimming. So we didn't test it in class, but we know that water is a conductor. Have you ever seen the warning label on a hairdryer and it says not to use a hairdryer near water? That's because electricity travels through water, so if we're in it when lightning strikes, we could get hurt. This is an example of how some conductors are not necessarily made out of metal, because water is also a conductor. Now you're going to show us what you know.